So for task number 11, we've got 3 problems, and problem number 3 goes on for several parts. You've already seen, again, task number 7, task number 9, very similar to this number 2 problem. We wrote equations like number 1 back in the last unit. So these 2 problems you should have enough background to do, so writing the equations and then solving them. I'm going to go ahead and talk about number 3, though. It's a little bit different and more involved. Below is the data on 4 cyclists riding along a road through the Black Hills. The variable x represents the time the cyclist has been riding, and y represents the cyclist's distance in kilometers from Rapid City. Not all of the cyclists started their ride at Rapid City, but all of them left at the same time and are riding in the same direction. So we've got Dan, and Dan's information is represented in a table, right? Maria is represented in a graph, Ryan is represented in an equation, and Helen is represented in a word problem. So these are 4 different ways of looking at the same kind of information. And so let's move on to number 3, A. Who is cycling the fastest, who is cycling the slowest, and explain. So what we're talking about right here is the rate of change. So we need to find the rate of change for everything. Well, Helen started cycling 15 kilometers from Rapid City. So she started out a little ways away from Rapid City, but she was traveling 50 kilometers in 2 hours. So this is her rate of change. And we can reduce that. 50 kilometers in 2 hours is 25 kilometers per 1 hour. So a unit rate of change will help us compare because we know that our y is in kilometers and x is in time, assuming we mean hours, right? So coming to Ryan, we see Ryan's equation. The slope is the same thing as rate of change. So we've got Ryan at 30 kilometers per hour. Here we've got Maria. She's going, we'll read the rate of change from the graph, and it looks like we've got a point here and a point here. So estimating like 20, 40 up and 1, 2 over. We've got her going 40 kilometers per 2 hours. Or at least it looks something like that. It's hard to tell if it's exactly those points, but very close. So that's approximately 20 kilometers per 1 hour. So far, we've got Ryan going the fastest. But then we need to do a rate of change for Dan. So Dan is going, let's see, he went from 70 kilometers to 145 kilometers. That's 75 kilometers in 3 hours. So that reduces to 25 kilometers per hour. So he and Helen are riding at the same rate. And that means that Ryan is going the fastest and Maria is going the slowest. So you can write that answer for A. B, will Ryan pass Dan, and if so, when? Well, because Ryan is going faster than Dan, then definitely Ryan will. But let's see, we'd have to calculate when, which means a good way to figure that out would be either to graph these or to come up with equations. And we've already got an equation for Ryan. So if I came up with an equation for Dan, that would be the easiest way to then solve that system. So Dan's equation is going to be y equals 25x. We know because we know the slope already. And then we want to know what the y-intercept is. So there's a couple of ways to find the y-intercept, but I'm going to do it just by reasoning. We know that every hour he travels 25 kilometers. So that means here when he was at 1 hour, he was at 70 kilometers. And that means at 0 hours, at the very beginning of the race, he must have been 45 kilometers away from Rapid City, right? Because in that next hour, he ended up 70 miles away, which was 25 more. So we can say that Dan started 45 miles away from Rapid City and then traveled ahead at 25 miles per hour. Ryan here started no miles away, started exactly at Rapid City, but then was going by 30 miles per hour. So for B, we can take the two equations, y equals 30x and y equals 25x plus 45. And again, we could graph these, or we can just set them equal to each other using substitution, the y, right? So substituting this in for that y, we've got 30x equals 25x plus 45. And then we can solve by subtracting 25x from both. 5x equals 45, divide by 5, x equals 9. And remembering that x is the time, then we can say that Ryan will pass Dan in 9 hours. Then we need to write that in a complete sentence. That's your job. Ryan will pass Dan in 9 hours. Will Helen pass Maria? If so, when? Okay, so Helen is going 25 miles per hour. Maria is going 20 miles per hour. So again, yes, definitely. Helen's going faster, so eventually she'll pass. We'll use the same method. And again, going ahead and calculating the lines, the equations, y equals for Maria 20x plus, and we can read right off the graph where she starts. She started 20 miles away from Rapid City. Helen is going y equals 25x miles per hour plus, and she started 15 kilometers from Rapid City, so plus 15. So again, we're just looking for the solution set. Y equals 25x plus 15, y equals 20x plus 20. We can set these two equal to each other and solve. So subtracting 20x from both sides and subtracting 15 from both sides, I end up with 5x on this side and 5 on this side. Divide by 5, and so x equals 1. So Helen will pass Maria in just 1 hour. Will Helen pass Dan? If so, when? So Helen going 25 miles per hour, passing Dan 25 miles per hour. No, absolutely not. This is because they're both going the same rate, right? So there's no way she's ever going to catch up to him. That's a no solution situation, and in this case it means Helen's never going to catch up to Dan. So the answer is no, and you can explain that. And then it says write a linear equation for each of the cyclists, graph the equations using graph paper or graphing calculator, explain how the graphs relate to your answers above. So that's your job. We already wrote the linear equations for each. You can graph them just like we did in the last unit and explain how the graphs relate. The best way to do that would be showing each of these intersection points and showing that these two don't intersect.